Alrighty, guys. The next thing that we're going to look at is stem and leaf plots and dot plots. All right. So up here you see a frequency table of fractions, and it states Martin recorded the number of miles he rode his bike each day for 27 days. Represent the data using a dot plot. All right. So we have our data. This is our frequency, and you can tell it's not really in any kind of order, but for 27 days, Martin rode his bike and he recorded the number of miles he rode each day. So here on this day, he rode 5 miles, 5 3/4 miles, 6 miles, 6.5 miles, 7 miles. So that's how much he rode on each day. Well, to put that data into a graphical representation that's easy to see or easy to understand and look at, what we use is a stem and leaf plot. And so the number of miles Martin rode each day, that's the title. The stem is representing our whole number, and our leaf is representing our fraction. It can also represent a decimal. And down here is our key or our rule, and it says 5, that's our stem, and there's our line right here in between our stem and our leaf. Our leaf is 3/4, it means 5 3/4 miles. So you can see how many occurrences he rode 5 3/4 miles. So how many times did he ride 5 3/4 miles? 1, 2, 3, 4. So if we were to look in our frequency table, we'd see that he rode 5 3/4 miles one time, 2 times, 3 times, and 4 times. Well, it occurs here, 1, 2, 3, and 4. So a stem and a leaf plot is it's an easier way to look at the data, to represent the data in order. All right. So how many days did he ride his bike? 10 miles. All right. We can try and find 10 up here in all this information, or we can just look at our stem and leaf plot and say, oh, there's 10, and zero force is 0. So he rode his bike 10 miles one day or one time. All right. So that's an easy way to look at it. Now, here it is also depicted in decimal form. 5 and 75 hundredths, 575 means 5 and 75 miles. And so you can put it in a decimal or a fraction format. So how many occurrences happened? Well, up here in our occurrence, it said 27 days. So we know there's 27 data plots right here. If we counted all the leaves, there would be 27. All right. And if we wanted to know how many times he rode his bike more than 6, but less than 7. So more than 6 or greater than 6, but less than 7 miles. How many times? Okay, well, we want greater than 6. So we're not going to look at these zeros here because that's equal to 6. Greater than 6 is 6.25 and higher. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 times, but we wanted less than 7. Well, here's 7. So we want greater than 6, but less than 7. So that's this information I'm circling, and that happened 9 times. 9 times out of how many was the total? 27. So I just created the fraction of time or days that he rode more than 6 miles, but less than 7, which is 9/27. That's a 7. Well, anytime we have a fraction, if we can reduce it, we reduce it. So we divide the top and the bottom number by the same thing. And I know that 9 and 27 are both divisible by 9. So what I do to the top, I do to the bottom. So I'm going to divide the top and the bottom by 9. That's my division there. That looks kind of wonky, but 9 divided by 9 is 1, and 27 divided by 9 is 3. So I know that 1/3 of the time he rode his bike more than 6 miles and less than 7 miles. So I'm able to look at the data and really analyze it. Now, down here, let's see, we have our stem and leaf. Down here, we have a dot plot of data. Determine if the dot plot or the stem and leaf plot represent the data. Explain your reasoning. Number of miles James rode his bike. Okay, so James rode his bike. Here it is in fraction form on you notice it's a number line, and it is broken down by fourth of a mile because this is 5 1/2, and then this is going to be 5 3/4, 6, 6 1/4, 6 1/2, 6 3/4, 7. And here is the stem and leaf plot. So every time something occurred, you're going to place it on the dot plot. Now this is a special dot plot. As you can tell, every dot is equal to 2 days. Every dot is equal to 2 days. So this one dot means 2 days, and this one dot means 2 days. And same here with 6. This dot means 2 days, and this dot means 2 days. So he rode his bike 4 times, equal to 6 miles. All right, guys. So as you can see, you can use stem and leaf. You can use a dot plot. Here's another dot plot. Now look at this dot plot. This dot plot has X's on it instead of dots. And as you can see, he rode his bike. Here's 5 5/10. So this is going to be 5 75/100, 6, 6.25, 6.5, 6.75, and 7. So it's broken down by quarter of a mile, or 1/4 of a mile, or 0.25. And so how many times did he ride his bike 5 75/100? 1, 2, 3, 4. 4 times. Well, if we looked at the data, 1, 2, 3, and 4. So the stem and the leaf plots and the dot plots are an easy way to look at data, how many times it occurs. It's an easier way to look at it instead of just a large frequency table. So you're able to look at this and say, oh, well, he rode his bike 7 miles. How many days? 1, 2, 3, 4. 4 days. All right, very good, very good. And did he ride his bike more, let's say 5 to 8 miles, or did he ride his bike 8.5 miles to 10 miles? Well, you can look at this and tell that the majority of the X's or the dots are on this side. And so you know he rode his bike less than 8 miles more often. So you're able to look at this data and really kind of take it apart and analyze it. All right, good luck, guys.